We have established the Dirac equation and checked the forms of alpha and beta matrices. Now we will see whether this equation is consistent with the equation of continuity and gives us the correct expression, acceptable expression for probability densities. We can recall that when we developed the Klein-Gordon equation, we saw that from Klein-Gordon equation, the expression of probability density, uh, the expression was something like that. For a real wave function, the probability density becomes 0, and it in some times it can be negative also. That was a limitation of Klein-Gordon equation when the relativistic theory of electron comes into play. So now we check if the Dirac equation can do it correctly. So the Dirac equation, as we have written, C alpha dot P plus m naught C square beta operating over psi. Both the operators are operating over psi, gives you I square del psi del t. This is the alpha matrix, alpha x, alpha y, alpha z combined here, and beta is another matrix, the other Dirac matrix. And now you use the momentum operator P equal to minus I h cut grad. So you just write the positive sign at the start and take the negative sign. This is just for writing, nothing else. And as the common practice, we have done it many times before in case of non-relativistic Schrodinger equation, in case of Klein-Gordon equation. We take the Hermitian conjugate of this equation 1, and as we see, we operate the dagger here. We apply the dagger over the left side operator, left side part, and then beta psi under dagger, they converts to psi dagger beta. Alpha dot grad psi under this dagger changes to grad psi dagger into dot alpha dagger. These are all known things to you. And as alpha and beta matrices are Hermitian, therefore beta dagger equal to beta and alpha dagger equal to alpha. So you obtain this equation. That is the Hermitian conjugate of equation 1. Be very careful in taking the conjugate of this one. You have to be alert, otherwise you may commit some mistake. And now again the common practice, we multiply this equation, we do the left multiplication by psi dagger on this equation and right multiplication by psi on this equation to maintain the order psi dagger psi. So by psi dagger into 1 minus 2 into psi, we obtain, this is the expression psi dagger into 1, this is the expression 2 into psi, and you see the first terms cancel out, and by combining these two, you see this expression, which can be very easily written as it is first order, it depends on first order derivatives of space. So the combining of these two terms in a single term is much more easier than it was in case of Schrodinger equation. In Schrodinger equation, the space derivative was in second order, so the application of vector identities was a bit complicated. So this is simply divergence of C psi dagger alpha psi plus del del t psi dagger psi. This term comes to this part and it becomes positive. I h cut is cancelled and it is simplified in this way, very simple form. And when you develop psi dot, grad dot this one, you will actually obtain divergence of psi dagger into alpha psi as this one. Divergence of psi, before that psi dagger alpha, this one, plus psi dagger divergence of alpha. I told divergence here, this is gradient of psi, grad psi, and this is grad of psi dagger. And here you will get grad dot alpha, gradient of alpha. divergence of alpha. I am mixing gradient and divergence. You try to understand what I mean to say mathematically. Just expand it. Other than C, you will get 3 terms. 2 terms are written here and the third term is 0 as divergence of alpha equal to 0. I think you got my point. While reading this statement, I made some mixing. And be very careful so that you don't do the mistake. So you replace C psi dagger alpha psi as J, which is the so-called probability current density, and rho as psi dagger psi. You get it from here. So this is the continuity equation. And now we check that as alpha and beta are 4x4 matrices and they are not numbers. So to satisfy the Dirac equation, this equation actually is a matrix equation where alpha is a 4x4 matrix and this psi has to be a 4 component column matrix, like a column vector. This psi has to be a column vector. That is, psi will be like psi 1, psi 2, psi 3, psi 4. These are 4 components of psi. So psi will have 4 components. So psi must be a column vector having 4 components. So psi dagger, if it is a column, psi dagger must be a row vector having elements which are conjugate of the column vector, psi 1 star, psi 2 star, and so on, you know. And hence you calculate psi dagger psi. This is clearly, there will be psi 4 here. Check. Psi 1 star, psi 1, psi 2 star, psi 2, psi 3 star, psi 3, psi 4 star, psi 4. There will be a psi 4 here. Make a correction. And hence psi dagger psi, all these are positive, and so psi dagger psi is greater than 0. So rho equal to psi dagger psi is definitely treated as a valid probability density. Note that this can also be 0. This can also be 0. This is surely non-negative. But this is 0 means all the components must be 0. All the components are 0, meaning psi will be a null vector. This will give you a trivial solution. Say any solution equal to 0 is acceptable solution, but you will get no physics from that. So having non-zero elements will give you a positive probability density. So we see that Dirac equation is consistent with the continuity equation and gives us an acceptable probability density. So we complete here.